x times it do it. Notice I don't even have a rule for that? That's okay. Watch this. I'm going to rewrite this. Sine x squared plus 1, and I'm going to stick the x out here with the dx. Because I know enough about derivatives to already know something. Okay, now, if that x was not there in the beginning of this problem, this would be a mean integral. If that x wasn't already there, it'd be a bad, bad day. But since it's already there, we're just going to move it out here. Yes, sir?
Is there a reason you left space right there?
There sure is, because look right here. The one I just worked, notice I had to put something in front of that dx to make it work. I'm already anticipating that. Okay, what's the u going to be? The u is what part? The u is which part? That part, right? So I go over here and I write what u equals. U equals x squared plus 1. Du equals what? 2x dx. So what is the only number I need right here? Because the x is needed as part of your what? Du. Now, if that x hadn't been there in the original, there's no way you could have made du, because you can't just put an x in there and then put a 1 over x out front. That doesn't work. All right. Somebody says, how did you get the 2x dx? Okay, right. U equals x squared plus 1, and take the derivative of it. 2 times x, derivative of x is what? dx. So you need a what? 2 here. If you put a 2 here, what's that going to make you do out front? Put a what? 1/2. Now you have the rule, because you have the integral sine u du. So you write down your 1/2 that's out front, and you get negative cosine x squared plus 1 plus 2. And what I'm trying to do here is get you to where you can recognize the u and make sure your du is really the right numbers. For right now, the variables are always going to match up. Okay? It's just the numbers that aren't going to match up for right now.
Wait, so you just put that 2 in there just to like.
So that would be my du.
So that would be your du, and then you put the 1/2 to just like
that
even
makes
everything
it.
out.
I didn't change the value of the equation. That's right.
Okay.
Because see, if I put a 2 here and a 1/2 out front, I'm still just multiplying by 1. There you go. And now you see why people don't get the right coefficients in the front, because they don't do this little bit right here to find their u and their du.
What's the negative 49?
Because the integral of sine u du is negative cosine u. Yeah. Man, to learn it. Rules. Okay. If you integrate secant squared u du, you get tangent u plus c. Because the derivative of tangent u is what? Secant squared u du. So far, so good. So, you have to integrate tangent squared theta plus 1 d theta. I haven't given you a rule about tangent squared theta plus 1, have I? Yeah, that equals what? Secant squared. So if you ever see any of these written to where you don't recognize it as one of the rules, start seeing if your identities can do what? Turn it into one of the rules. And then, of course, it's secant squared theta d theta. That just integrates to being tangent theta. Let's see. Because the u is equal to theta, and the du would be equal to, so one of the things I will throw at you about this trig is if you don't see one of your 6 rules, and actually there's going to be 10 by the time this is over with, if you don't see one of your 10 trig rules, the first thing we'll try to do is see if there's an identity that will do what? Turn it into a trig rule. Is that a get the point? Okay, we'll see if you get the point. I've got sine x, no, sine 3x cosine 3x dx. Well, there is no rule for sine u, cosine u, is there? It's not a rule, is there? No, there's not one, is there? Give you a hint. I'm going to put 2 here and a 1/2 out front. Not for calculus, but because of trig. Look on the back of your purple page that you're supposed to have from last year. This is when that purple page becomes really important. Is there some way to turn what you're looking at right now into one of those rules over there to the left? It's okay that you don't know now, but it won't be okay not to know next year. What is it? Can't find our purple pages. Get somebody to get you one that's in my pre-calc class. You will need it. All right. 2. I'm not going to make fun of you. Sine theta cosine theta equals sine of 2 theta. See, that's the reason I put the 2 there. I got 2 sine theta cosine what? Theta. So that equals sine of 6x. Then I can use my rule. The u part is not the sine of it. The u part is just the what part? The what? What's just the u part? Say it. No, right here. What's the u part? 6x. And if u is equal to 6x, what number do I need right here to make my du without me even doing it and writing it down? I need a what right here? And if I put a 6 there, we'll put a what out front? 1/6. So I get negative 1/12 cosine 6x plus 6. But the trig identities come in very handy. I'm going to teach you some trig identities this year for when these are not the same even. Like if this was 3x and that was 2x, this rule wouldn't work. I'm going to teach you some trig identities to make those work because they come in real handy. Because if you can turn something into plain old sine or plain old cosine, it's easy to integrate. All right? Okay, there's 3 more rules for trig. And they all work the same way. You got to have a u and a du. The other 3 rules. The integral of cosecant squared u du is equal to negative cotangent u plus c. The integral rule for okay, Oh, the integral rule for secant u, tangent u, du is equal to secant u plus c. Secant, tangent. Yeah, I'm going to remember my derivative rules. I can't remember my derivative rules. Okay. And then the integral for cosecant u, cotangent u, du is equal to negative cosecant u plus c. So those are your 6 rules that you got from taking derivatives of trig rules last year. Or earlier this year. When you were doing derivatives of calculus, if you took the derivative of tangent u, you got secant squared u du. If you took the derivative of secant u, you got secant u, tangent u, du. So those are the reverses for all of the 6 that you had. And here's the problem. You don't have a reverse for secant u, du. And the reason you don't have a reverse for it is there's nothing that you've ever taken the derivative of that gives it to you. Is that okay? Yeah, there's not anything that gives you that. Well, yeah, there is. Natural log, absolute value, secant u plus tangent u plus c. That's what you get when you integrate secant u, du. You get all that. And if you want to know why you get all that, it's on the video from this morning. But I'm just going to use the rule. I'm not going to. Because on the video this morning, I didn't ever use the rule. And here I'll actually use it. And there I derived the rule. And here I'll actually use it. And then y'all can watch each other's videos. Yeah, I'm a lazy public educator. So that's what happens. All right. I have the integral secant pi over 2 times x dx. All right, I already know the u is the part that's after the trig function. Does everybody understand that the u is, later on the u will include the trig function. But for right now, the u is the part what? After the trig function. Because these are the trig rules. Okay, so what is the u going to be over here? Tell me what u equals.
Pi over 2x.
Yeah. So what does du equal? Dx, right? So what do you have to write in this blank right here? Pi over 2. And if you write pi over 2 there, you better write what out front? And then you simply use the rule. The integral of secant u du is the natural log, absolute values of secant u plus tangent u plus c. So what we're trying to do is get you to where you recognize a u, a du, and then you can integrate it. And the reason I'm doing this is if you look at all the integration rules, they all have u's and du's. There's a part that's going to be the u, there's a part that's the du. And what you do is the part that's the u, you see if you can get the du out there. And as long as the x's match up and you don't have too many x's or too few x's, it's awesome. Now, I'm going to go ahead and give you the rule for cosecant u. For cosecant u, du is equal to the natural log of cosecant u minus cotangent u, absolute values plus c. And there's a couple more. 6, 7, 8. What other 2 have I not given you? Okay. Sine, cosine. Have we integrated just plain old tangent? No, we haven't, have we? That's right, yeah. Okay. The integral of plain old tangent u, du, because there's nothing we've ever taken to get to rid of that, is natural log secant u. Yeah, it's natural log secant u. Well, see, I had to work it out in my head. Or it's negative natural log of cosine u. It's either one, okay? Bring the negative back in here and make it a power means take the reciprocal and you get secant u. So you'll see this in books and you'll see what? This. That's a big old or. Or. And the rule for cotangent u, du, is natural log sine u plus, yeah, sine u plus c. All right? And that's all 10 of the trig function integrals. There's 10 trig function rules, and there they are. All right? That takes care of any of your basic trig. Now, it doesn't take care of sine squared. It doesn't take care of cosine squared. But I'm going to show you how to do those at a later date. All right? But here's the whole catch, folks. If you know the rules and you know how to make u du, that's the key right there. Is that when you know what the u is, you know how to make the du. And the catch is, for right now, you're going to put a constant here and the reciprocal out front. See? We put the constant here, we put the what? Reciprocal out front. When you get to the harder ones, yeah, you can't do that on the hard stuff. This is all the easy ones, because the du is easy to make. All right? When you start, if you were to throw an x out here, or an x squared, there'd be a problem, because the x's won't match up. As long as the variables match up, it's easy. That doesn't last forever. Now, Mr. Evans is going to brag for just a second.